Hi everyone, welcome to this class where we are going to look at factorization of polynomials. Factorization is a super important topic in mathematics and it's used whether you're in class 8, 9, 10 or even higher classes. Very important concept, and I'm going to make this really easy for you. So keep your pen and paper ready and let's become masters of factorization. Now, before we begin, I just want to say, do check out the other courses on our website. We have physics, chemistry, biology and maths for CBSE class 8, 9 and 10. So guys, if you haven't taken the other courses, do take them and do share it with your friends. For the ICC students, we have physics, chemistry, biology and maths courses for classes 8, 9 and 10. And if you want to learn coding, we have Python programming, we have Java coding. Both are great languages to learn computer programming. And we also have physics and chemistry for the Cambridge IGCSE, which is the international board. So do share out our courses with your friends. Make sure you have subscribed to our YouTube channel. You can also follow us on Facebook and Instagram. So stay connected with Manocha Academy and keep learning. So what is factorization? I'm sure you have heard of this topic or you have done this before. For example, if I tell you to find the factors of 6, what are they? So 6, we can write it as 2 times 3. So what we are doing is we are breaking 6 into its factors or the prime factors here. This is prime factorization. Of course, you can write 1 also, but 1 is neither considered prime. 1 is a factor, 6 is also its factor, but these are the prime factors. Similarly, if I ask you to break 30 into its prime factors, can you do that for me? What is 30? It is 2 times 3 times 5. What are the prime factors of 12? So 12 is 2 times 2 times 3. So this is what you have done before in arithmetic, right? So this is basically prime factorization. Breaking a number into its prime factors. But what we are going to learn in this class is factorization in algebra, factorization of polynomials. So let's take a look. So just like we saw, when you multiply the prime factors, right? So when you do 2 times 3, what do you get? You get the number 12. Similarly, if I ask you to find this product, right? Let's say you have these two factors, or what you have these two expressions in the brackets, right? X plus 2, x plus 3. So this is like finding the product. So how do we simplify or find the product here? We expand it. So if you expand this out, what are you going to get? You're going to get x times x, which is x squared. Then you'll get a 2x and a 3x term. So that's going to give us a 5x and plus 2 times 3, which is 6. So this we say is finding the product. Just like if you do 2 times 3 is 12, this you do in arithmetic, this in algebra is finding the product. Now factorization is the exact opposite of it. So here we are turning the product into a sum. In factorization, we do the sum of expressions. We want to find its factors, or we want to turn it in a product form. So x squared plus 5x plus 6. What are the factors? The reverse. The factors here are x plus 2 times x plus 3. This is called factorization, right? It is just the opposite of finding the product. In finding the product, we expand it, we simplify it. Here we are doing the reverse. When we find the factors, we express it as something times something. These are its factors. Similarly, if you have been given a question like 2x squared plus 11x plus 5, can you find its factors? How do we do that? There are many methods of finding these factors or factorizing these. This is a polynomial. Polynomial means it is having this x square x, where the powers of the variable are whole numbers, non-negative integer. So how do we factorize polynomials like this? We are going to learn all the different methods and I'm going to make it super easy. So let's start. Now before we look at the methods of factorization, you may be thinking, why am I learning factorization? What's the use? So let's understand it. Let's say I ask you to simplify, do this division. So you have been given x squared minus 7x plus 10 divided by x squared minus 3x plus 2. One option is to do the long division, right? So you go ahead and divide this polynomial with this. So do that long division, find the quotient and remainder. Another option is if we could break these polynomials into its factors, into the product of its factors, maybe some factors will cancel out. Let's take a look. So if you factorize this, some of you may already be knowing how to factorize it, but let's say you don't know. And just believe me for a moment, let's say we factorize this and we get these as the factors. X minus 2 times x plus 5. Even if you guys don't believe my answer, you can multiply this out and see if you're getting the same thing. See, x square, there's a minus 2x minus 5x, so minus 7x, minus 2 times minus 5 plus 10. How did I do this? We'll look at the methods. So we have taken the numerator and broken it into its factors, which is factorization. Let's do that for the denominator as well. So denominator, you'll see the factors are x minus 2 times x minus 1. Again, you can confirm it. Just multiply this, x square, the minus 2x minus x minus 3x, minus 2 times minus 1 plus 2. Now what you'll see over here, the x minus 2 gets cancelled. So can you see that this complicated expression, we have simplified it simply into x minus 5 divided by x minus 1. And just like we say, we should simplify our lives. Don't complicate your lives, okay? Einstein also said, beautiful things are simple. So same way, if you have complicated expressions like this and you could easily simplify it to this, wouldn't that be great? And who helps us? Mr. Factorization. So we are going to see what are the techniques of factorization. Similarly, it helps us solve these kind of equations. If you have been given, so what type of equation this is? This is actually a quadratic equation because there is an x square. So if you have been given this equation, you can solve it very quickly by factorization. Solving means find the values of x where x square plus 5x plus 6 equals 0. How do we do that? Let's say we factorize this polynomial using the methods we are going to learn into these factors. Once again, you guys can confirm it. Just multiply it out. You'll see x square, 2x and 3x, 5x plus 6, 2 times 3. Okay, so this is our equation. Now we want to solve this equation. So solution is very easy because if you have these two products, it can only be 0 if either this is 0 or this is 0. So what will be the solution here? So either x plus 2 equals 0 or x plus 3 equals 0. So that means x is minus 2. I am going to take 2 to this side, or x is minus 3. That's our answer. So see, factorization made solving that quadratic equation really simple over here. So what are the factorization techniques? We are going to do 9. There are 9 methods actually for factorization. You may say, oh my God, so many methods. Don't worry, we are going to take a simple example or maybe 2 examples of each, and I'm going to make it really easy. So these are the factorization techniques that we are going to be learning today, and we'll start with the first one, which is the simplest one, called taking out the common factor. So what do you do in taking out the common factor? Whenever you have an algebraic expression like this, right, these polynomials, the golden rule is take out all the things that are in common. So what do I mean by that? Like if I tell you to factorize this, it is having these two terms, 5x square and 20xy. Now take out the things which are common in both. Okay, it's like if there are two friends, what are the common hobbies they have? Let's say both like watching cricket or playing cricket, both like playing, let's say, table tennis, both love traveling. So those are their hobbies or their likings. Okay, so same way here, what is common to these two terms? Can you guys tell me? So you can see 5 is common because 20 is also divisible by 5. So 5 is a factor, and x part is common. There's an x squared, but there's only one x. So see, I can simplify this as this. So can you guys see that this expression is the same as 5x times x minus 4y, or you can treat this, these are the two factors, but since this is 5x, we usually write it without the brackets. Same way, can you take out the common factors here? If you have 5a, b plus c minus 3b, b plus c, can all of you see that b plus c is common to the two terms? Just like the 5 and the x was common here. So please take that out. So the common stuff must come out. So b plus c times 5a. So see, we have changed this expression into a product of factors. This is factorization. And always check, is there anything common they left out? No. So this is my final answer. So the first one is clear. So we have looked at the first one, and you must do it first because it will simplify your thing. If there is any common factor, please take it out. Let's look at the next one, which is very interesting. It's called grouping of terms. So let's see that. Let's say if I have got x square minus 5x plus x minus 5. So first thing, always check, is there any common factor in all the terms? Like take out the common factor. Is there anything common? X square is there, so x is there in these three, but x is not here, so I can't take it out. And 5 is also not there everywhere, so nothing common. But what we can do is, we can group certain terms. So let's say we group these two guys and we group these two guys. So what do we get? So if we are considering x square minus 5x and then the x minus 5. Now let's see, we can take out some common factor here. So what is common between these two terms? X. So this becomes x times x minus 5, and this one I can write it as plus 1 times x minus 5. Now if you take a look at these two terms, they magically seem to have x minus 5 common. You guys can see this part is common now. Yes or no? X minus 5 is common to the two terms. So take out the common factor. So we are going to get x minus 5 times whatever is left. So x is left here and 1 is left here, x plus 1. And factorization, the beauty is you can confirm if you multiply this thing out, if you simplify it out, you will get the original expression. See, x square minus 5x plus x minus 5. Some of you might be thinking, why didn't they write minus 5x plus x as minus 4x? We are coming to that. That is called middle term breaking. Here it was already done for you. So minus 5x plus x, if you actually simplify it out, then you'll have to do again that breakdown to get the common factors. So we have looked at taking out the common factor and grouping. Let's go to the third method, difference of two squares. This is a very famous one, very popular one. So what does this say? If you have an expression like a square minus b square, that can easily be factorized into a plus b times a minus b. And you guys can easily confirm this. If you do the product here, a plus b times a minus b, if you expand it out, it's going to be a square plus ab minus ab minus b square. So you can see that the ab or minus ba, that ab will get cancelled. So this is a square minus b square. So therefore, a square minus b square can be easily written as the product of a plus b times a minus b. So how we can use it for factorization? Let's try out this example. If we have been given a square minus 4b square, so what will be the factors here? We can write this one as a square minus 2b whole square. Do you guys agree? 2 times 2 will give you 4 and b square. So now you can see we have a square minus something square, or you can treat this as x square minus y square. So what is it going to be? Say it in your mind. A plus b or x plus y. So a plus 2b times a minus 2b. So you have to take this term plus this term minus this term, and there you can see we have it. Let's try to factorize this one. 9x square minus 25y square. Can you guys do this for me? What will be the factors here? So here we have 3x whole square minus 5y whole square. So very important to write it as the difference of two squares. This is 3x whole square, this is 5y whole square. Again you apply a plus b times a minus b and say it in your mind while you're writing it. So say it to yourself, a plus b 3x plus 5y multiplied by a minus b 3x minus 5y. So if you guys say it in your mind, you will never get it wrong. You won't write something wrong by accident. A plus b, right? 3x plus 5y, a minus b. Or you can write the formula on your side and compare it and then write it. So see, difference of two squares easily helps us to factorize it. So we have done the first three techniques here. Now let's look at using binomial identities. What are the two important binomial identities? A plus b whole square. Binomial means it has two terms, so a and b. A plus b whole square is a square plus 2ab plus b square, or you can learn it as a square plus b square plus 2ab, whichever way you like. And a minus b whole square is a square minus 2ab plus b square. So this is again expanding it out. It's, if you multiply this a plus b times a plus b, you'll get this. A minus b times a minus b, you'll get this. But in factors, remember, we are doing the opposite. We're converting the expression into a product. It is converting the expression, that sum of terms, into a product. So for example, here if you see this kind of thing, you can see you have a 4x square, you have some 9y square, and then you have a 12xy. So can you tell which identity should I use to factorize this one? Should I use a plus b whole square or a minus b whole square? What do you guys think? So look here and compare it, right? You can see that all the terms are positive here. In a square plus 2ab plus b square, all terms are positive. In a minus b whole square, there is a negative term. So obviously we need to use the first identity. Meaning of identity is that these expressions, these formulas are true for any value of a and b. Whatever value you plug in, they are true. That's why they are called identities. They are equalities for all values. So we can apply it here as well. If you look carefully here, these are the two square terms. This is the product. So this term is like our a square. This term can be like our b square. And this term is like our 2ab. But we need to confirm if it is fitting the formula. We cannot just blindly apply the identity just because we got excited, we saw some squares and xy, let's go for the identity. No. Mathematics is not rough work, right? We have to check it. So let's do here. So 4x square is nothing but 2x times 2x or 2x square. 2 times 2 is 4x square. 9y square is nothing but 3y whole square. Now follow me very carefully. What you need to check here, this 12xy needs to be of the form 2 times a times b, which means it needs to be of the form 2 times a is the first guy over here, 2x, times the second guy, 3y. So you need to confirm 2 times 2x times 3y, if you multiply 2 times 2 times 3 is 12, x times y, xy. So we are all good here. That means we can use the identity. So we are going to use the a plus b whole square identity. So our expression is nothing but 2x plus 3y whole square, or you can write it as so whatever method your teachers prefer. If they want you to write it as a square or write it 2 times, both are correct. So see, we have taken this expression and broken it down into its products, into its factors. Clear? And what have we used? Using a plus b using the a plus b whole square identity. So the important thing is to spot the identity. What are your clues? You had a square term, another square term, and then an xy. And then you need to check if it fits the identity. That's great, because you can easily use it to factorize. This will come with practice. So yes, the main thing is to check if it is really this perfect square, because you can see these identities are a perfect square, a plus b whole square, a minus b whole square. and this is the checking you need to do here. Similarly, can you guys try to factorize this one for me? So again, hint for you is you have to use one of those identities because we are talking about binomial identities and applying them for factorization. So please try this one. So there you can see we have a square term here. So maybe this is like our a square. You can start thinking in rough. This guy might be like our b square. And we need to check if this guy is like our 2ab. But you can see there is a minus here. So a square minus 2ab plus b square. Last time we had a square plus 2ab plus b square. So which identity we'll use here? Definitely looks like we are looking for the a minus b whole square identity because there's a negative term here. So now go ahead and try it out. So one simpler thing is, you can see there's that x plus y. Maybe you can, to simplify this, you can say let x plus y equal to a. So we can write this expression as 4a square minus 20 ya plus 25y square. All I've done is let x plus y equal to a. Okay. So this expression is much easier to look at. You can see there's a square, there's a y square, and this ya, maybe you can write it as a ay. So this we can clearly see it is a 2a whole square. So this expression is nothing but a 2a whole square. There's a 5y square here, 5y whole square, and this we need to check is minus 2 times 2a times 5y. See, 2 times 2 times 4 times 5, 20. So looks like we are all good over here. So therefore what are we getting? This is nothing but 2a minus 5y whole square. Do you guys agree? A square plus b square minus 2ab. So 2a minus 5y whole square. So should I end the answer here? But remember, we did this assumption, let x plus y equal to a. So you need to go back and substitute that here. So what will we finally get here? So substituting x plus y or a as x plus y, we are finally getting 2 times x plus y minus 5y whole square. Again, you can simplify out this thing. So what will we get? We are getting a 2x plus 2y minus 5y whole square, which is nothing but 2x minus 3y whole square. Very good. You guys have got this answer, 2x minus 3y whole square. So see, when you write x plus y as a, things become much simpler. The important trick is to see, okay, you have a square, you have another square term, you have a minus here. So write that in rough and see whether it is fitting the identity. Important thing to check is that term fitting that 2ab or 2xy formula. If equation has two minuses, then definitely you cannot use this one, Medhani. So great, we have completed 4 methods here. Taking out the common factor, grouping, difference of two squares, and using binomial identities. Now let's look at using trinomial identity. What is the meaning of trinomial? Just like tricycle has 3 wheels, trinomial has 3 terms here, a plus b plus c whole square. Don't you guys remember riding your tricycle before you learned your bicycle? So here we are going to look at trinomial identities. But in childhood, tricycle was simple, bicycle was difficult. Here's the opposite. Trinomial is this complicated thing, right? A plus b plus c whole square is a square plus b square plus c square plus 2ab plus 2ac plus 2bc. Like this identity never ends, okay? So you need to remember this formula. Actually, it's not that difficult. The easy way you can learn is, there are all these squares, a square plus b square plus c square, and just like you had a 2ab in a plus b whole square, here you have all the combinations, 2ab plus 2ac plus 2bc, okay? You have to take them in pairs. So this is your identity. So if you are given some expression like this, you know it is going to be nothing but a plus b plus c whole square, or a plus b plus c times a plus b plus c. So let's see if we can factorize this, guys. So you can see there's a 4x square, there's a y square, there's a z square, 4xy minus 2yz plus 4xz. So can you guys factorize this for me? Can you guys factorize this for me? So the important thing here to see is, you can see that these are all your square terms. And these guys seem to be all your 2ab, 2ac, 2bc, these kind of terms, right? So this part seems to be matching with this part. So main thing to confirm is, does the pattern match? Is it following that 2ab, 2ac, 2bc? Please check it. So let's start by writing this stuff. So 4x square is nothing but 2x whole square. This is y square. This is a z square. Now you can see we are getting a minus 4xy here. Okay, so minus 4xy, should I take minus 2x or minus y? Maybe I'm going to go ahead and take it as plus 2 times 2x times minus y. Okay, let's say the y term is negative. So that means this is nothing but minus y whole square, which is same as y square. Okay, so here we have minus 2yz. So I am going to take it as plus 2 times minus y times z. See, because in my formula all the terms are connected with positive, so I am trying to fit it over there. And then we have a plus 2x plus 2 times 2x times z. So for this to fit perfectly, since we have minus y over here, I can always put a minus y whole square here, right? Y square is the same as minus y whole square, because these terms have to match. So finally, what is the answer we are getting? We are basically going to get 2x plus the minus y, which is minus y, plus z whole squared. Because you can see there is a 2ab, there is a 2x times minus y, there is a minus y times z, so a bc term, and then a 2xz. So all the terms are matching. So this is 2x minus y plus z whole square. So all you have to do is just match this with the formula and match each term how we have brought it. Why I had to take a minus y here? Because I want to change everything into positive. So I shifted the minus. I can shift it into the x or into the y. So I chose to shift it into the minus y. If you had shifted into the x, you would have got the same answer. You would have got something like minus 2x plus y minus z whole square. Some of you might have got this. If you kept your y as positive, then your x and z terms would be negative. Then only we'll get these negatives, right? And the minus minus will give me positive. Because see, we have a negative term here. So either that x has to be negative or the y. Then only you can get a negative product. And here the x and z are both giving positive. So either both are positive or both are negative. Now you may say, okay, these are two different answers. Actually, they are not different. Because if you take the minus common, so if you take minus 1 common, you are going to be left with this, which is nothing but 2x minus y plus z whole square. So as you guys can see, this and this are the same. Both these guys are the same thing. So whether you take 2x minus y plus z or minus 2x plus y minus z, if you take that minus 1 out in common, you're going to end up with the same answer. Don't learn different combinations like a minus b plus c, a plus b minus c. No, that's not the way. All you have to do, if you're thinking of a minus b plus c, then you just substitute minus b into all of these. So this minus b whole square becomes b square. This 2ab will become minus 2ab and this will become minus 2bc. Because you can't learn so many combinations here. So that is why use the positive one, and any term you just shift the minus sign, you take either b, c or a as negative. So we are done till here now. We have looked at 5 methods Now let's look at splitting the middle term of a quadratic polynomial. This is also famously known as, we're going to look at middle term breaking. So this method is called middle term breaking. Very important, very famous method. So suppose you are asked to factorize x square minus 5x plus 6. Now you can see there is no common factor. Grouping will also not help. So grouping helps when there are, even number of terms like 4 terms. So here you are having only 3 terms here. So grouping will not help you. So what do? We will convert these odd number of terms, 3 terms, into 4 terms by breaking that middle term. So what is the technique to break the middle term? You don't want to try random combinations, right? Minus 5, should I break it into minus x minus 4, minus 2x minus 3x? What should I do? So the main thing is to break this middle term. This is my middle term. So the simple technique is, you look at this constant here, the number, right? So you look at the product of that first and the last term, and you look at the numbers. So there's a 6x square here, right? So just look at the constant or the number part of it. So we are dealing with the number 6. Now you break it into its factors. What are the factors of 6? Either you can write it as 1 times 6, or 6 can be written as 2 times 3. So you need to choose those factors which, when you add them up, they will give you the middle term. Listen to this carefully. You need to select those factors which, when added up, will give you the middle term, but also with the correct sign. Initially, don't think too much about the sign. Just write it as 1 times 6, 2 times 3. Now when you're selecting it, it should give you the product of 6, and the sum should be minus 5x. So for example, if you take them as, since you want minus 5x, so at least one of the terms has to be negative. Both cannot be positive, because then the sum won't be negative. So what should you take? Either you can take minus 1 and minus 6, or you can try minus 2 and minus 3, because you want negative guys here. So what you can do is, you can try minus 1 times minus 6. See, the product is still 6, so product is fine, the sign of the product. Or you can try minus 2 and minus 3. Now when you add these guys, they should give you minus 5x or minus 5, right? Because they are basically, it's a 6x square. So when you add up the terms, that x remains. So which one will you select? Minus x and minus 6x will give you minus 7x. But minus 2x minus 3x added up gives you minus 5x. So definitely we will go for these factors. So I can break the middle term as x square minus 2x minus 3x plus 6. See, I have made no change in the expression. Minus 5x has just been broken down, middle term splitting, breaking into 2 parts. Okay. Now the advantage is, you have converted your odd number of terms into 4 terms even. Now go for grouping. So what is the grouping you're going to do here? X is common here, so we'll write it as x minus 2. Here 3 is common, so minus 3 times x, and minus minus is plus, so minus 2. Now you can see x minus 2 is common, times x minus 3. So did you guys see, with this middle term breaking magic, we have found the factors of this. Once again, the systematic method is, look at the product of the first and last term. So it's a 6x square. So the number is 6. Forget about the x square for now. Break it into its factors, and then select those factors with the correct sign, so that when they are added up, they give you this. They give you the middle term, and the product of the factors should be back to that original number, which is 6 here. So this is how you get it. Is this clear? Can you try this one by middle term breaking? So here what will you look at? You have a 2x square and a 5y square. So take the product of the first two. So again, we'll ignore that x square, y square for now. It's 2 times 5, 10. So we want a product of, so what are the factors of 10? Either it's 1 times 10, or 10 is 2 times 5. So which factors will you take so that the sum of the factors adds up to 11, and the xy will come automatically, because you'll be taking one as an x, one as a y. So should I take 1 and 10 or 2 and 5? To get 11, obviously I need 1 plus 10. 1 plus 10 is 11. 2 plus 5 is 7. So we are going to go for this combination. So we are going to split that middle term like this. This one we'll just copy down 2x square. This will break it down as xy, which means 1xy and 10xy. And simply copy this term down. So see, we have done middle term breaking so that we get the right product with the sign, right? So 2 times 5 will give us the 2 times 5 is 10. You can see the product is same here, 10. Now, so if you multiply xy times 10xy, see you're getting 10y square, xy times 10xy will give you the product of the first two terms, first and last term. Now you have converted your odd number of terms into even terms, just do grouping again. So we are going to do, we'll take out the common factor from this group, it's going to be x times 2x plus y and 5y times 2x plus y. Now you can take 2x plus y common. Times x plus 5y. So can you guys see how we have taken our expression and easily broken it down into its factors using middle term splitting or middle term breaking. So we have learned 6 methods. That's great. All these 6 we have taken care of. The last one we did was middle term breaking. Now let's look at sum and difference of cubes. So till now we have been dealing with squares. Now we look at cubes. So we have done a square minus b square, that can be factorized as a plus b times a minus b. But note one thing, that a square plus b square cannot be factorized. So there is no identity for that. But when we come to the cubes, both of them can be factorized. A cube minus b cube is a minus b times a square plus ab plus b square. So this is an identity. And then a cube plus b cube can be broken down into a plus b times a square minus ab plus b square. So in cubes both works, a cube minus b cube, a cube plus b cube. In squares, only a square minus b square. There is no formula for a square plus b square. Now what is the easy way to remember the cubes? I remember it this way, a cube minus b cube. So if the first factor contains the same sign, a minus b. A cube plus b cube contains a plus b. The next factor contains the opposite sign. There was a minus b here, here is going to be a square plus ab plus b square. There was a plus b here, it's going to be a square minus ab plus b square. So you can see that the only difference in these factors is in their signs. So just be careful of the signs here. So these cubic, a cube minus b cube, a cube plus b cube, these cubic terms can easily, difference of cube or sum of cubes can easily be broken into these factors. Yes, there is this common question that a square plus b square, I can write it as a plus b whole square. Is this correct? That is a square plus b square plus 2ab. These are not equal. So there is no identity for that. You need a plus 2ab. But this one is correct. A square minus b square is a plus b times a minus b. So let's try out these identities and see if we can factorize this guy. So if we have a cube plus b cube plus a plus b. Again you can see there is nothing common we can do here much, right? So what we can do is, or if you were try to do some common thing, you could say a cube plus a, b cube plus b, but then you will be left with a and a square plus 1 plus b times b square plus 1. So then you're going to get stuck because there is nothing common. So what we are going to do smart is, we are going to take a look at this a cube plus b cube and then apply this identity. So what is a cube plus b cube? It is nothing but a plus b times a square minus ab plus b square, and then there is another plus a plus b. So what you can see, a plus b is common. So now we can take that. So this is nothing but a plus b. So this a plus b means 1 times a plus b. So this becomes a square minus ab plus b square plus 1. There's our final answer. We got it. Let's see if we can use these identities to factorize 16a to the power 4 minus 54a. So what is the golden rule? First check if there's something common you can take here. Is there something common that I can take? Looks like it, because I can take 2a common, and then I'm going to be left with the 8a cubed minus 27. Yes, 27 times 2 is 54. So we have taken our common stuff, 2a. Now what you can do here, this is nothing but 2a times 2a whole cubed, and 27 is nothing but 3 cubed. So you can see we are in cubic land because we have 2a cubed minus 3 cubed. So which identity we can go for? A cube minus b cube. So let's apply that. So we can see that this is going to be 2a times a cube minus b cube is a minus b. So 2a minus 3 times 2a whole square plus ab. So 2a times 3 plus b square, 3 square. So if you simplify this further, you're getting 2a times 2a minus 3 times 4a square plus 6a plus 9. And here we took a plus b common, so we were left with the plus 1. Here again we got a cube minus b cube, so we use the identity a cube minus b cube here. So we have done all these techniques, taking out the common factor, grouping, difference of two squares, using binomial identities, using trinomial identity, splitting the middle term, which is called middle term breaking, and sum and difference of cubes. So we have these two left, which is the x cube plus y cube plus z cube minus 3xyz identity and factor theorem. So these are the 9 important techniques. I've really made it easy for you guys to classify and think of which technique to use. So let's take a look at the 8th one here. So here we are going to look at x cube plus y cube plus z cube minus 3xyz identity. So these identities are very useful in factorization because you can see we are changing this addition or subtraction, right? This sum or subtraction of terms into products. So this is a very interesting identity. It's a very long one, so even I find this difficult to learn. What does it say? X cube plus y cube plus 3z plus z cube minus 3xyz. That's going to be equal to these two products. So first product is easy, x plus y plus z, but the second product is very long. And last batch, they called this the anaconda identity. It's so long. X square plus y square plus z square minus xy minus yz minus zx. So it's like an anaconda snake. Okay. So there you can see this thing has been broken down into these two products. So you can see it is going to be useful in factorization if we see this kind of form. Now one very useful thing about this is that if this first product x plus y plus z equals 0. So look at this. If this x plus y plus z is equal to 0, that means if this is 0, then what can I say about this right hand side? 0 times this bracket means the entire thing is 0. Yes. So if this thing is 0, that is if we say if x plus y plus z, sum of these three guys is 0, then we can see the RHS is 0. Now if the right hand side is 0, I'll directly equate this like this. So therefore I can say x cube plus y cube plus z cube minus 3xyz is equal to 0. Now if this is equal to 0, we can rearrange this and say or x cube plus y cube plus z cube, I can take this way, equals 3xyz. So this is often used, that's why you should take care. If by chance the sum of these three terms is 0, then you can actually get a very interesting relation here. Clear? So let's see how we can use this identity to factorize this. So this looks like a complicated question, but this identity makes it simple. How to recognize this identity? You'll be having 3 cube terms and this x, y, z kind of term, right? So can you see there's a cube, there's a b cube, there's a c cube, and then there is this term here. So now take a look carefully. If you look at the identity, it is the form of x cube plus y cube plus z cube. So let me start writing this. 2 root 2 a cube. Is it a perfect cube? Yes, if you write this as root 2 a whole cube, because the a times a times a will give you a cube, and if you multiply root 2 times root 2 times root 2, what will you get? Root 2 cube. So root 2 times root 2 will give you 2. So this is 2 root 2. Yes. So you are going to get root 2 of a whole cube plus this is going to be 2b whole cubed minus 3c whole cubed. But if I write it like this, there is one problem because there is a minus sign here, but my identity has a plus sign. So what can I do here, guys? So what is the smart thing we are going to do here? We are going to put the minus inside. So we can simply say plus minus 3c whole cube. So because minus 3c times minus 3c times minus 3c will give me minus 27c cube. So see, I'm trying to match it to the identity. That is very important with the signs. And the last part is going to be, there should be a minus 3xyz. So how can we get that? We have to see that does this last term have the same pattern. If it doesn't, then you can't use this identity. Please don't force it into the identity. So let's check if it has it, that form. So 3xyz. So you can see this is like my xyz. This is my x term here. This is my y. And this minus 3c is my z. Okay. So please multiply these terms and check. So 3 times root 2a times 2b times minus 3c. Please multiply all these guys and see what you get. If you multiply all of this, what will you get? 3 times 3 is 9 times 2 18. So this is giving me 18. Minus minus will cancel. So plus, right? So plus 18 root 2 ABC. And can you see it is perfectly matching the term given here. So that means this is fitting into our identity x cube plus y cube plus z cube minus 3xyz. So now we can put these cubes here also, x cube plus y cube plus z cube minus our 3xyz. Is this clear? So if it is matching this, now we can easily factorize it. So what will be the factors? So the factors are going to be, the first factor is simply x plus y plus z. So you just have to add up these terms. Root 2a plus 2b minus 3c. And please add it with the correct sign. Okay, it's a minus 3c. Now the next is the anaconda bracket, right? This long snake. X square plus y square plus z square minus xy minus yz minus zx. So now do it carefully. X square means you have to square this. So root 2a whole square is going to be 2a square. Second term if you square, 2b whole square is going to be 4b square minus 3c whole square. So that's going to give me plus 9c square. Minus minus becomes plus. Then what do we have? xy. So xy means I have to multiply this term by this term. So that's going to give me plus 2 root 2 ab. And similarly keep continuing. Oh, it's going to be minus xy. Sorry, so my mistake. So when you multiply this, you have to keep the minus sign. Then we have minus yz. So if you multiply this term and this term, so minus minus will give me plus. So 2b times 3c, so that's going to be 6bc. And then finally we have minus zx. This term and this term. So minus minus will again give me plus 3 root 2 ac. So there you can see this is the final answer. So it looks like a dangerous question, but if you can recognize it is this identity, it is very, very simple to factorize just by using this formula. So it is a product of these two guys. That's it. Clear? And you have to carefully match and match your terms, the x cube, the y cube. So carefully write them down and use this formula. Yes, you can take a minus common here also, xy plus yz plus zx if you want, or you can learn it like this, whatever is convenient for you. The trick to learn this formula, you can see there's a pattern. First we are summing all the individual terms, then we are summing all the squares, x square, y square, z square, And the last is the pairs, minus xy minus yz minus zx. Similarly, use this identity and see if you can evaluate this minus 12 cube plus 7 cube plus 5 cube. So again, when you see these 3 cubes, you will get reminded of this form, x cube plus y cube plus z cube. But one interesting thing is, so this is like an x cube, this is like a y cube, this is a z cube. Now one interesting thing is, if you add up this x, y and z, so x is my minus 12, y is 7 and z is 5 here. If you add these up, if you do x plus y plus z, what do you get? 7 plus 5, 12, minus 12, a big 0. So if you add this, that means we can apply this special condition which says, if the sum of my terms, if x plus y plus z is 0, then this x cube plus y cube plus z cube is very simple. So one way is you might say, I'll evaluate this by cubing these, but that will take a long time. We know that the sum of this is 0, so we can be smart here and say that this thing is nothing but 3 times xyz. Who is my xyz? 3 times minus 12 times 7 multiplied by 5, and we are done. It is equal to 3xyz only if this is true. If x plus y plus z is not equal to 0, then you can't use this. It has to be equal to 0. So now just sit and multiply this and you are done. So here you can be smart. You can take the 2 here because 2 times 5 will give 10. So basically what do we have? Minus, we'll take the minus out, 3 times 6 times 7, and I've taken the 2 here, times 10. It's easy to multiply with the 10. 7 6 are 42, and 42 times 3 is going to give me 126, and then you have the 0. So there you go. That's the answer, minus 1260. So simple. If you had done it individually by cubing, it would have taken you a long time. It turns into a very simple multiplication of 3xyz. That's it. So we have done 8 methods. We are left only with factor theorem. We have done all these factorization techniques. Now let's see how we can apply the factor theorem. And please watch my video if you haven't watched it yet. There is a video on remainder and factor theorem. Do watch that. So let's recap. What does factor theorem say? If fx is a polynomial of degree greater than equal to 1 and a is a real number such that f of a equal to 0, which means you substitute x equal to a in this polynomial and you get 0, then we can say that x minus a is a factor of fx. So when is this factor theorem method used? When none of these 8 methods work, because these first 8 methods are very fast. If you can see the identity, or you can see how to factorize it or group the common terms, it's very fast. But if none of these 8 methods work, factor theorem is like our backup plan, like our plan B. We'll see how do we use it, because it is more of a hit and trial method. So suppose you are given something like this, x cube minus 6x square plus 11x minus 6. You may try very hard, but none of those, it will not fit into any identity, no grouping, middle term breaking will help here. So what do we guys do now? We will go for factor theorem. Factor theorem basically says that if you substitute different values of x, which is written as a over here, and if you can get this polynomial, because you know this is a polynomial, if you can get it equal to 0, then you have found at least one factor. This x minus a is basically you have found a factor of the polynomial. Now once you have found the factor, things become easier because you can divide it and break it down into a smaller polynomial and see if you can factorize that further, or again you might have to use this factor theorem of hit and trial. Now the interesting thing is, what values of x should I try so that it becomes 0? I can randomly try things like 0, 1, 2, 3, minus 1, minus 2, minus 4, minus 5, minus 6, whatever, right? But what do I use here? So there is a smart technique here which goes something like this, that if you're given a polynomial like this, look at the final constant given to you. The constant you can see is 6 here. Can you guys tell me what are the factors of 6? So what are the factors of 6? 6 we can write as the factors 1, 2, 3 and 6. No, we won't try plus infinity to minus infinity, right? We are going to be smart here. So the smart technique is look at that constant and break it down into its factors, okay? Because this will help you get to it probably faster. It may or may not work, right? Because if there could be fractions involved, but usually this will help you. Now you can see these are the factors. So now you just put a plus minus sign in front of the factors and try these values first. Plus 1, minus 1. Plus 2, minus 2. Plus 3, minus 3. Plus 6, minus 6. And that should get you to a factor of this polynomial. Okay. So for example, let's try. So we are going to try substituting x equal to 1 first. So we are finding out f of 1. And let's see what do we get here. Here we are getting 1 cubed minus 6 times 1 square plus 11 times 1 minus 6. So please work it out. What does this give you? This is a 1 minus 6 plus 11 minus 6. So that's 12 minus 12, 0. Wow, we are lucky because we found the factor just with the first try. This is like a hit and trial method. You have to try these different values. Plus 1 minus 1, plus 2 minus 2, plus 3 minus 3, plus 6 minus 6, whichever one where you hit. And here you can see f1 is 0 when I substituted x equal to 1. That means who is the factor? Look at the factor theorem carefully. Can you tell me therefore who is the factor of this guy? So based on this we can say therefore x minus 1 is a factor. Because read the theorem carefully, it says if f of a equal to 0, then the factor is actually x minus a, not x plus a. So x minus 1 is a factor. So I have found one factor. Now how do I find the other factors? One is you can do simple division, right? So you take this polynomial and you do the division here. Maybe we can shift this here. So since x minus 1 is a factor, we are going to sit and divide this. So we are going to do x cubed minus 6x square plus 11x minus 6, and we are going to divide this entire thing with x minus 1, which basically means doing the long division. So quickly do that, guys. So the first term, to get an x cube, I will multiply with an x square. So I am going to get x cube minus x square here. If you subtract these guys, so you can see this becomes a minus, this becomes a plus on subtraction. And what do we get here? This will cancel out. Minus 6x square plus x square, so we are getting minus 5x square plus 11x. Now how do we get this? We want minus 5x square, so we can put a minus 5x over here. So that's going to give us minus 5x square minus 5 times this will give me minus minus plus 5x. Again do the subtraction, so this becomes a plus, this becomes a minus. These terms will cancel. 11 minus 5x is giving me a 6x minus 6. So what do I need here? I need a 6x. So I'll use plus 6. And you can see all these guys are cancelling and we are finally getting a remainder of 0. So what have we got in the division? That this guy is nothing but equal to x minus 1 times this quotient x square minus 5x plus 6. So see, factor theorem has helped us to find one factor. Now the other part, again try those techniques. Don't use factor theorem again. See if you can use these techniques like middle term breaking or looking at for some identity and see if you can factorize it. If you still can't, then again you'll have to go for factor theorem. Yes, this is the other factor, but let's see if we can break it down further. So can you guys break down x square minus 5x plus 6 with me? So we can use middle term breaking here. So we can say, so we are going to do middle term breaking only on this part. So what do we get here? Because minus 2 times minus 2 or minus 3 will give me 6. And so these are the, I have broken the middle term there you can see. So let's factorize this. So x times x minus 2 minus 3 times x minus 2. Clear? Why did I break it? Because 6 has the factors 2 and 3. So either you can take 2 and 3, but 2 plus 3 will not give me minus 5. So I have to take minus 2 and minus 3. Because I want the product to be plus 6, sum to be minus 5. Like we discussed in middle term breaking. So these are the two factors. And now you just do the grouping x minus 2 times x minus 3. So finally, who is our, what are the final factors of the question? So we can see therefore answer is going to be, the first factor was x minus 1 and here are the other two factors, x minus 2 times x minus 3. There you can see we have the three factors of our polynomial and we have factorized it using the hit and trial method. So first in hit and trial method, use the factor theorem, find one factor, then use the division method, get to the quotient and then factorize that further. Is this crystal clear how to use the factor theorem? Let's try another factorization question. We have 3x to the power 5 minus 48x. Can you guys factorize this for me? So see what are the methods you can use. We have learned so many methods. Always start with the easiest one, like taking out common factors, trying grouping, then go to the identities, and if nothing works, your backup plan is factor theorem. So let's try to factorize this guy. So always first see, can you take out something, because the golden rule is take out the common stuff. That makes it easy. So is there any common stuff here? Yes, x is in common and 3 is also in common. So I can write this as 3x times x to the power 4 minus 16. I am grouping out the common terms. Always, are we done? Some of you may think, okay, done. But always check if you can further break it down into the factors. So we have x to the power 4 minus 16, which I can write as, this is nothing but x square whole square minus 4 square. So can you see we have a difference of two squares? So we can use a square minus b square is going to be equal to a plus b times a minus b. We can apply that here. So what are we going to get? 3x times x square plus 4 times x square minus 4. Are we done? Is this our final answer? Is this going to be the final answer? Yes or no? Check if you can factorize it further. So we know that a square plus b square cannot be broken down. Remember, we cannot factorize a square plus b square. But again, we have a square minus b square here, I think. We have the difference of two squares. So once again, we can apply this identity here as well. So I think finally we are going to get 3x times x square plus 4. And this is nothing but x square minus 2 square. So x plus 2 times x minus 2. That's the final answer here. Isn't this easy? But take care. The golden rule is, please ask yourself, can I factorize it further? Double check. Don't just end it here or here. Check and then you will see that we have broken it down into 1, 2, 3, 4 factors is the final answer here. So hope you guys enjoyed this factorization class. So hope the factorization techniques are clear to you, and please, practice those techniques, try to apply the grouping, identities, and the best way to learn all these identities, write them down, and of course, if nothing works, you can go for hit and trial with the factor theorem. And do check out the other courses on our website. We have physics, chemistry, biology, and maths for CBSE class 8, 9, and 10. So guys, if you haven't taken the other courses, what are you waiting for? Do take them and do share it with your friends. For the ICSE students, again, we have physics, chemistry, biology, and maths for classes 8, 9, and 10. And if you want to learn coding, we have Python programming, we have Java coding. Both are great languages to learn computer programming. And we have physics and chemistry for the Cambridge IGCSE, which is the international board. So do share out our courses with your friends. Make sure you have subscribed to our YouTube channel. You can also follow us on Facebook and Instagram. So stay connected with Manocha Academy and keep learning.